Here we have a university system consisting of students, lecturers, courses, and schools. Schools as in School of CSE or School of Mathematics. And these entities interact with each other. Lecturers teach courses. Every course has a lecturer in charge, or LIC for short. Students enroll into courses, and every school has a lecturer as the head of the school. These are what we refer to as relationships. But some of these kinds of relationships have extra rules or constraints that govern how many times a given entity can be involved in a particular relationship. For example, every course is required to have at least one lecturer that's teaching the course. In other words, every course is required to participate in this relationship at least once. But some other entities don't have such restrictions. For example, students are allowed to take as many courses as they want throughout their time at uni. And lecturers are allowed to teach any number of courses including 0. So they can even choose to not teach any courses. So in this video, as we go through each of these relationships one by one, we are going to look at how to indicate these kinds of constraints in an ERD. First up, we have lecturers teaching courses. A lecturer can teach many courses, and a course can have several lecturers. So that's called a many-to-many cardinality ratio between lecturers and courses. And you can show that in an ERD like this. We have two entity sets, lecturer and course, and they're connected through this relationship set. Here's an example of a system consisting of 3 lecturers and 2 courses. You can see that Sam teaches Com 1000, Isaac teaches both Com 1000 and 2000, and Rudra teaches neither of the two. Just like Rudra, a lecturer doesn't have to be teaching any courses, so we say that the entity set lecturer is participating partially in teaching. On the other hand, every course has to have a lecturer teaching the course, so that's a total participation, which is denoted by doubling of the line. Next up, we have students enrolling into courses, and it's the same many-to-many ratio again. A student can take several courses, and each course can have many students taking the course. But this time, there may be some courses that do not have any students enrolled in the course yet. Perhaps it's a new course, or maybe it's just not very popular. So we don't put a requirement that every course needs to have at least one student taking the course, and hence we keep it as a single line meaning partial participation. Along the same lines, you could say that new students just starting out their uni wouldn't have enrolled into any courses yet, so that's partial for students as well. Now let's go back to lecturers and courses, but this time it's about lecturers in charge. Well, a given lecturer could be the LIC for multiple courses, but a course cannot have more than one LICs. So this time we put down 1, meaning every course is limited to the maximum of 1 LIC. And that's indicated simply by using an arrow for the side corresponding to the 1. And we say lecturers to courses is of cardinality ratio 1 to many. If you were to read from the other direction, courses to lecturers is of ratio many to 1. Although it might seem pretty straightforward, this is actually where lots of people trip up. The common mistake that people make looks something like this. First, they start off with their entity sets and their diamond in the middle. Then they say lecturer can be the LIC for many courses, so they place a simple line next to the lecturer. And they say it's a maximum of 1 LIC per course, so they put down an arrow next to the course. Well, as you can see, the arrow now got placed on the wrong side. So with 1 to many ratios, you got to be extra careful with where you place your arrows. One way to double check your ERD is to convert it back into words like this. First, reading from the left to the right, a lecturer, skip a line, can be in charge of many courses. Then scanning from the reverse direction, you read a course, skip a line, can be in charge by, at most one, lecturer. So all we did just then is scan the diagram from both directions, and for each direction, translate every notation you encounter into words. And the key point is to always skip the first line. So let's try that again, but this time with the incorrect version. First, in this direction, a lecturer, skip a line, can be in charge of, at most one, course. And a course, skip a line, can be in charge by many lecturers. Obviously, these two sentences don't make much sense, so that tells us that we put the arrow on the wrong side. So this is the way I double check personally, but if you don't like it, you can always come up with your own way to verify your ERDs. Anyways, let's finish this one off by adding on the notations for participation. It's optional for lecturers to be an LIC, so it's partial on this side, but it's mandatory for courses to have an LIC, so it's total on this side. Alright, lastly we're talking about lecturers, schools, and their heads. A lecturer can be the head of a particular school, but we cap it to the max of one school at a time, simply because being the head of one school makes you busy enough already. Also, every school gotta have exactly one head lecturer. So that's an example of a 1-to-1 ratio which you can show with an error on both sides. Okay, moving on to participation. Not every lecturer has to be a head, so it's partial on this side, but it's total for the other side since every school should have their own head. Now if you put everything together, you get something that looks like this. And that's it, that basically covers all of the cardinality and participation constraints. Obviously we didn't look at all the possible combinations of the constraints, but you should still be able to deal with those situations as well. That being said, make sure to go through more examples and exercises so that you can test your understandings on the topic. Alright, thanks for watching, I will see you in the next video.